In these first few lessons with Algebra 1, we've really been focusing on numbers and how to manipulate and operate with numbers. And we've done a little bit with expressions where we have variables and we're plugging some numbers in, but not a lot of what a lot of people would consider algebra. And that's because the foundation for everything that we are going to do needs to be laid very well before we can move on. And this is the last lesson in this series. So once we're done with dividing real numbers, we're going to go into solving equations. And hopefully at this point, the solving the equations is going to feel very easy because of the knowledge and the skills that you built up with the numbers. So keep that in mind with math. Math is really all about layering on your skills. And if you do it correctly, it's never that hard because each layer builds on a strong foundation and it's not too much at once. So a few lessons ago, we talked about like adding real numbers. So we had something like 4 plus -6. And we developed a way of dealing with those on the number line where you would start at 0. And then a positive number means you're going to the right. And a negative number means you're going to the left. And so you would go, in this case, 4 to the right, and then 6 to the left, and that would land you at -2. And so 4 plus -6 would be -2. Then we got to subtraction. And the way that I approached that in these videos was to really not deal with the subtraction at all. And so when we got to subtraction, we pretty much said, no, there's not actually a thing called subtraction. Subtraction is just adding the opposite. And that is a great way to think of subtraction. So that enables us to get around having to learn separate rules for subtracting, because if subtracting is just adding the opposite, then we can integrate what we know about opposites and we just turn all our subtraction problems into addition problems. So if I had -5 minus 3, rather than try to tackle that as like, oh, what's that subtraction mean? Like, oh, 5 minus 3 is 2. And you can kind of get a little bit tangled in that. Change that to adding the opposite. And now it's -5 plus -3. And with enough experience, you can just start to picture that on the number line. So you go 5 to the left, and then you're going to go 3 more, which means you're going to land at the -8. Well, we're going to take that same approach with division. We are going to approach this as division isn't really a thing. You're first grade, not first grade. I don't know when we learned division. I don't know, like 4th grade. They lied to you. There's no such thing as division. And all those little manipulatives where you took like 12, for me it was little red dots and you put them into piles of 4 and how many piles do you have and all of that. Nope, not a thing. We're going to redefine division so that we can leverage what we know about multiplication and actually kind of avoid doing something new. So division is simply multiplication by the reciprocal. And we want to make sure we know all of our vocab here. Okay, we want to make sure we know what a reciprocal is. Otherwise, that doesn't help you at all. Like multiplication by the reciprocal, that's nice. What is that? The reciprocal is pretty much the flip of a fraction where you would switch the numerator and denominator. Okay, so there's your reciprocal. So if I have a fraction like 2/3, the reciprocal would be 3/2. If you have 1/4, the reciprocal would be 4/1 or simply 4, since 4/1 is just 4, or 4 divided by 1 is just 1. Or sorry, it's late. Now, if you had something like 3, the reciprocal of 3, you would have to remember that's really 3/1. And so when you go to take the reciprocal of 3 is 1/3. Okay, so now that we've established what a reciprocal is, what does that have to do with division? So suppose you had 12 divided by 4. Well, that is the same as 12. Take that, division. Division is multiplication. So that becomes multiplication by the reciprocal. So the reciprocal of 4 is 1/4. So 12 divided by 4 is the same as 12 times 1/4. And now you can use all your multiplication rules and you don't have to learn anything new about signs or anything like that. Just it's all going to work. Now, where you might get a little tripped up on this is if you're not really good with fractions, but most of the time when you need to invoke this definition, it's not going to be an issue. So the first bank of problems that we'll look at is just to rewrite a division problem as a multiplication problem. So for example, you might have something like 3/5 divided by 2. So 3/5 divided by 2, that is 3/5 times, and then we want the reciprocal of 2, just remember that that is over 1, so that would be 3/5 times 1/2. And you could carry it out, just make sure you're following the directions, so it might just be like practice with the rewrite, or the directions might ask you to actually do something. Now it happens that multiplication of fractions is actually the easiest thing to do. When you're multiplying by fractions, you just multiply straight across the numerator and straight across the denominator. You do not need to have a common denominator. So 3 times 1 is 3, and 5 times 2 is 10. And so 3/5 divided by 2 is 3/10. Okay, we'll do another one of those. Let's see. Oh, this is a good one. Well, let's do this one first. 3x divided by 1/3. So don't let the division freak you out. Division is just multiplication by the reciprocal. So we're going to take out our division, do multiplication, and then we want the reciprocal of 1/3, which would be 3/1. But there is no need for us to write over 1. And there are times when we want to remember that there's a 1 there, and sometimes we might use it like when we're graphing lines, but we don't need it now. And now we can do this out. 3x times 3 is just a quick little review here. That's 3 times x times 3, and then because multiplication, you can multiply in any order you want. You can go ahead and switch the order, which gives you 9x. Nobody typically does that, okay? Okay, well, just, yeah. Nobody typically does that. You would just do 3 times 3 and jump right to the 9. Let's look at one more. This kind of looks ugly, but it's one of those things that looks worse than it is. Okay, so this is 12, and then remember that in math, the primary way that we write division is with a fraction bar. Okay, so normally in math, we do not write 1 divided by 2. We would write just 1/2. Okay, and we would use our fraction bar to indicate division. So that's the operation there. So what I'm going to do with this problem is just a quick little rewrite, and listen to what I say, and then what I say in words I'm going to translate into what I'm writing. So this is 12 divided by 2/3. Okay, 12 divided by 2/3. So this is 12 divided by 2/3. So what I did there was I used the way that I would say that, and I did a symbol substitution where I just replaced the division symbol. So instead of using that fraction, I went back to like the middle school little division symbol there. And the reason I did that was because that makes it easier to invoke the definition. So this is really 12 times the reciprocal. So the reciprocal of 3/2 or 2/3 is 3/2. And then we can go ahead and multiply this. So we are going to have 12 times 3, which is 36. And 1 times 2 is 2. And then 36 divided by 2 is 18. So notice in that how we kind of go back and forth between using the fraction bar and using the other division symbol. It's just one of those little tricks that you can use to make things easier. I don't want to scare anybody, but this kind of situation is called a compound fraction or a complex fraction, where you have a fraction inside a fraction. So like the denominator of the fraction is a fraction. They look really ugly, but they're not actually that bad to deal with. So now everything that we've studied thus far comes into play. So everything that we know about like sign numbers is also going to work. So for example, if you had 10 divided by -2, well, that's 10 times 1 over -2. You could put that negative in the numerator as well, or you could put it out front. So you could do something like this, okay, where it's out front, either or, it's fine. So that is 10 times 1, well, yeah, which is 10, yeah, I think just for consistency, let's put it down there. So 10 times 1 is 10, 1 times -2 is -2, and then we know 10 divided by 2 is 5, and then we know a positive times a negative would give us a -5. That was not my best explanation that I've ever done. That was just not the greatest thing I've ever done. Let's do another one and see if we can clarify that a little bit better. So this next one is -1 divided by 3. And so this would be -1 times the reciprocal of 3, which is 1/3. And then we would multiply going straight across. So -1 times 1 is -1, and 1 times 3 is 3. I think the bottom line with that is that just like with multiplication, if you have 2 positive numbers, the answer will be positive. And if you have 2 negative numbers, the answer will also be positive. And then if you have opposite signs, that's when you end up with a negative answer. Let's take a look at a couple more that are a little bit nasty there. Let's do -1/3 all over 4. So this is another one of those compound things where you've got a fraction within a fraction. And I'm going to do the same thing I did the first time. -1/3 divided by 4. Okay, -1/3 divided by 4. So -1/3 divided by 4. And that just makes it easier to take that reciprocal. That's -1/3 times the reciprocal of 4, which is 1/4, and then multiply going straight across. -1 times 1 is -1, and 3 times 4 is 12. Okay, I think where you end up engaging the multiplication by the reciprocal is mostly in these situations where you have like a fraction within a fraction. It's not the kind of thing that comes up most of the time, and most students are pretty comfortable with their division. Anyway, what we just want to remember is that the sign rules are the same as for multiplication. So like signs results in a positive answer, opposite signs will give you a negative answer. I'm going to do one more example of one that is an algebraic expression. So we're going to go do evaluate 2a minus b over ab when what? A is equal to -2 and b is equal to -3. Okay, so we know enough now about algebraic expressions that each variable represents a number, and these are the numbers we're going to use. So I have 2. I'm going to take out the a and put in a -2. Minus b. Now just be careful there. This minus was in the formula. This minus came in with the b. Okay, so there's actually 2 negatives there. And then in the denominator, we're going to have -2 times -3. Let's take this one step at a time. Don't try to take shortcuts. 2 times -2 is -4. Subtraction means to add the opposite. So this is adding. What is the opposite of -3? +3. And then in our denominator, a negative times a negative gives us a positive, and 2 times 3 is 6. In the numerator, -4 plus 3, well, I go left 4 and then right 3, which is going to land me at -1, and then I have the 6 in the denominator. Don't panic when you see a problem like that. You know everything you need to know to be able to get to the answer. Just take it one step at a time. Don't try to skip steps, leave yourself plenty of space to work. And that's pretty much everything there is on division of real numbers. It's just multiplication by the reciprocal. So as always, I'm going to put some practice problems on the next slide and then go over them. Okay, so what we have here, the first three are just write the problem as multiplication. If you would like to do it out, that's fine. But the directions are just to write as multiplication. For the next two, and it's 16 divided by 4, 2x divided by 1/9, and 4 divided by, or 4 over 3/4. For the next three, you actually do need to perform the operation. That's 92 divided by 1/2. Negative 3 over 4 divided by 4, and negative x over 4 divided by 3. And then the last one is evaluate AB over 2a minus 8 when a is equal to 8 and b is equal to 10. I do read them out loud because I know my handwriting is kind of terrible. So you can see it. Pause the video, work the problems out, and then check your answers when you come back. Okay, so for these first three problems, we're just going to write them as multiplication, and I might go ahead and do them out just for those of you that might have gone through that process. 16 divided by 4, it's multiplication by the reciprocal, and the reciprocal of 4 is 1/4. Now, this is one where I truly believe it's easier to conceptualize 16 divided by 4 because that's the division fact that you've probably had memorized since about 3rd grade. So it's easier to do that. In a case like this, you probably wouldn't think to rewrite it as multiplication by the reciprocal, but like it's okay too. And it's a good exercise because there are times when you really do want to write it like that. So we want to practice in advance of seeing those situations. The answer to this should be 4. Second one, this is one where you do want to rewrite it. So we have 2x divided by 1/9. Well, that's weird. We want to reimagine that in our heads as 2x times the reciprocal of 1/9, which is 9. Now, earlier in the lesson, I did the rearrangement step where I said, remember, this is multiplication. You can switch the order. But I said, we normally don't do that. Normally, we just look at the two numbers. We know we can multiply them because of the properties of multiplication. And so 2 times 9 is 18. So you would have 18x. And then this last one, we have, well, I don't know why I'd rewrite it. It's right here. So 4 divided by 3/4. Now notice I'm playing that verbal game where I'm using a different word to help me visualize what's happening. This is 4 divided by 3/4. So that's awkward. We're going to rewrite that as multiplication. That is 4 times the reciprocal, which is 4/3. Remember that that is a denominator of 1, and we're just going to multiply straight across. So 4 times 4 is 16. And 1 times 3 is 3, and it is perfectly okay for you to leave your answer like that. Always be aware of what the directions say to do. Actually, and what's the directions here, we're just write as multiplication. So if you stopped it there, you're fine. You did what the directions ask. But if you are doing the problem out, if it doesn't say leave it as a fraction or leave it as a decimal, you're free to leave it however you want. Okay. These ones we actually do need to do out. So if you stop the other ones early, you can't do that here. Number 4, we have 92 over 1/2. So in my head, what I'm going to say is that's 92 divided by 1/2. So 92 divided by 1/2, which is still kind of weird to think about. It's not half of 92. That's not what it is. It's 92 times the reciprocal of 1/2, which is 2 over 1. But then nobody really wants to write over 1. So really that is just 92 times 2, which is what, 184. Number 5, we have negative 3/4 divided by, whoa, I added 2 whole pages to my presentation here. Negative 3/4 divided by 4. And so we're going to rewrite that as multiplication by the reciprocal. The reciprocal of 4 is 1/4. and then go ahead and multiply straight across. So -3 times 1 is -3, and 4 times 4 is 16. So -3 over 16. These are problems where you legitimately do really want to kick in that definition. This one over here, probably not. Like it's not practical. But these ones, yeah, like most of us need to envision this as like the fraction with the multiplication in order to get it. Last one of those types is this one here. We have negative x over 4 divided by 3. So we're going to do negative x over 4 times the reciprocal of 3, which is 1/3, and then multiply straight across. Negative x times 1. Well, anything times 1 is the anything. So that's going to give us negative x, and then 4 times 3 is 12. And then the last one is evaluate. And I like these problems because they really start keeping fresh like the vocabulary. So evaluate, what does evaluate mean? It means plug in the numbers and then simplify it. So we've got AB over 2a minus 8. So a is 8, b is 10, so that's going to be 8 times 10 over 2 times 8, and then I'm going to change that to plus -8. You do not have to do that. I just want to keep reinforcing that that's what subtraction is. In the numerator, 8 times 10 is 80. In my denominator, 2 times 8 is 16. Then we keep the 80, and then 16 minus 8, or 16 plus -8 is 8, and 80 divided by 8 is 10. And so that whole thing simplified to 10. There are other ways that you can do that, but that's a pretty good way. And that concludes actually our second unit in this study of Algebra 1, and we're going to move into solving equations next.